this session, we are going to discuss how to handle exceptions in Python. Okay, exceptions are basically errors that crash our programs. So that is why we must anticipate and handle these exceptions to prevent our program from crashing. So that is the objective behind handling these exceptions. Okay, um, let's see an example. Let's see. So the syntax of the exception code block is goes something like this. So we have a try block, and in that try block, we can have some code, right? So we can write some code here, and then sorry, let's go ahead and write the code itself. Uh, let's say there is a variable x equals hello. Okay, excuse me. And now we're going to write a try block, try print x plus 3. And then we are writing an except block, then trying to print something went wrong. That's it. So this program has a try except block. So initially we are creating a variable x and assigning a string to it. The string is hello. And then in line number 3, we are trying to find the sum of these two numbers. So which should throw an error because the 3 is an integer and x is a string, and we are trying to perform a mathematical operation on that. So in general, so if this error comes in, the moment the error comes, it will come to accept block and print our customized message saying something went wrong. Okay, so if I run this, excuse me, it is throwing something went wrong. So now this is more readable for other developers or users. They can understand, that, and you can make it more meaningful for them. Basically, the idea is that we are displaying a user-friendly message. Otherwise, what happens? Let's say we don't have this try catch block, and simply if I want to write print x plus 3, now this is going to throw me an error something like this. All this it will appear, trace back, and all this information, and then it's a type error and can only concatenate string to the cannot concatenate string and integer. So that is the issue. Okay, so in order to prevent this kind of system driven error message, we can write our code inside a code block or or inside an exception block. Now, in addition to try and accept, there are two more uh, block here. One is else. So else will execute if there is no exception. Okay, so if I am printing no errors occurred, and then we have something called finally. So finally will always execute no matter what. I can give program completed. Excuse me. Now this is the whole try catch or try except block. So try except else and finally. Okay. So let's see this once again. Try block has our code, the logic, and the code that we write. And if there is any error in that code, it will come to the accept block, and then we can give here whatever message we want to. And if there is no error, okay, then it goes to else part, and it will print no errors occurred. And then finally, so finally we'll execute anyway. Okay, so let's see this program. Sprint, something went wrong, and then program completed it is coming. no errors occurred did not come. Okay. Now, if I assign a numeric value to it, so I assign, let's say, 4, now there should not be any error. Actually, no errors occurred, the value got printed, no errors occurred, and then program completed. So this is the syntax and the process how we handle exception. Okay. All right. In this example, we are catching the error in general. That means whatever error comes, it is going to throw same message. Something went wrong. Now, there is a way you can accept or you can handle specific errors. Okay, there are some errors, um, such as, so this error that occurred now. If I give here string, this error is a type error. So if I remove everything, and now when you see, it's going to throw me type error. So now you can specifically capture type error. Now, for example, if I comment line number 1, now it is throwing me name error because x does not exist. The variable x does not exist. So two errors we have seen: name error we have seen, and type error we have seen. Okay, so let's handle this independently. Okay, uh, so let's give our code. Let's give it as a try block. So I'm giving. Let's write it from beginning. So I'm giving try. Then I'm trying to print x. Now, x does not exist actually, so it is going to throw a name error. I'm going to accept, and specifically I can mention name error and print variable does not exist. Now, this could be more meaningful. And then I give here else block, print. And this else block is not mandatory. You can actually ignore that. This else block you don't have to give, and even finally you don't have to give. The most important the parameters are try and accept. Now if I run this program, this is going to throw me an error called variable does not exist. Now we have captured the name error because the variable x does not exist. Now let's say I have, now I'm creating a variable x equals hello, and here I'm giving x plus 3. Now, if you notice, the variable x exists. However, in line number 3, when we attempt to perform addition on x and 3, it should throw a different error. Meaning, name error won't occur, but something else will occur, which we are not handling. If I run this, now it is showing the system driven error message. See, type error can only concatenate string, not int. Now, what we can do, we can handle this error also. So, what we do, we give another except block, and I give type error. Now, print meaningful message. Uh, Variable x should be integer. Okay, so now it is more meaningful. Now, if I run this, variable x should be an integer, and so there are two errors, right? Name error and type error. So this is how we can handle multiple exception at a time. Okay. Um, let's say I want to capture name and type error together and give a general message. Okay. So that for that I can give both the errors in bracket. I give name error, comma, type error, and then in the in this block, that means one of these issue occurred, either name error occurred or type error occurred. Okay, So we can give a generalized message saying variable x does not exist. Okay, or variable x should be, or variable x is not, it's not an integer. So this is the reason why error occurred. So now user can double check this. Okay, we run this and see variable does not exist or variable x is not an integer. So both the errors we are capturing. Now anything else apart from this, if occurs, then again system error would occur, right? So we are specifically capturing only these two errors. Okay, all right. So this is about handling multiple exception. Um, let's see another example. I'm going to open a file. Let's say my file.txt, my students.txt, and I'm trying to open this um, in a read format. So if I give this, that means I'm trying to open a file which does not exist. Okay, so if I run this, it is showing no such file or directory, and the error type is file not found error. Okay, file not found error has occurred. So what we do, we give this statement inside a try block, right? And then give except I'm giving file not found error, and then trying to print file does not exist, please try again. There is a little bit extra message that I'm able to give. Try this, showing file does not exist, please try again. We have captured file not found error. Okay. Uh, in addition to the system driven or system specific exception, we can raise our own exception actually, which will display like system. So that means if I just try to print x, which does not exist, if I try to print this, it's throwing a system driven error, right? The name error, name x and all. Now we can also raise an exception like this. Okay, so let's say I want to check a condition, x equals 5. Now checking condition, if x is less than 5, then I'm trying to raise exception x should be x should not be less than 5. Now this exception we are raising. So the instruction is raise exception. So like how the other exceptions are occurring here below, similar fashion you would see this exception also. Okay, so let's say it is 6 if x is less than 5, right? So let me make it 3 and 3. So now I'm getting an exception. See, exception x should not be less than 5. Okay, so this is how we can raise custom exceptions through raise exception command, okay, or code. And so that way other developers can read your code. I mean, when they're executing your code, they can get to know what exactly is the issue, right? That means there are two ways we have learned. One is we can capture the system exception and throw our own message, a meaningful message. The other thing that we have seen is we can also raise exception from our end, which will look like, how the other exceptions, the system exceptions, appear. Okay, so with this, we can end this exception handling. Uh, the basic thing that we have covered is the syntax. So let me uh, give you the syntax one more time. So we have the try block, okay, try block, and here is our code, and then we have except block, and then else block, and finally. Okay. So try block will have our code, except block will run if there is any error, and if there is no error, then else block will run, and finally block will run anyways. It will run all the time. Okay. So that's it on exception handling. Thank you.